All right, this is the continuation of the 2.7 video examples. Starting with part B, we're solving the inequality and expressing the solution in terms of intervals whenever possible. So to be able to start this off, we want to always get everything on one side and equal to 0. So we're going to distribute this x. So this would be 3x squared minus x. We're also going to subtract over that 4. And then we're going to try to factor the quadratic that's on this side. So 3 times negative 4 is negative 12, and factors of negative 12 that make a negative 1 in the middle would be a negative 4 and a 3. So using factor by grouping, we will split this into two numbers in the bottom, or the middle. Factor each by pairs. So that's a 3x and an x plus 1. Minus 4 we can pull out, and that would make that x plus 1 when we pull the negative out. So we get x plus 1 as one factor and 3x minus 4 as the second factor. Our critical values are what would make each of those equal 0. So negative 1 would work for the first one, and imagine solving this. You would add 4 and divide by 3, so 4/3 is the second one. We place those numbers on our number line from least to greatest. This is an equal to, and there's no fractions, so everything, as long as you're a polynomial, you just obey the symbol here. So that's going to be closed and closed. This is negative infinity to negative 1, bracket, bracket negative 1 to 4/3, bracket, bracket 4/3 to infinity. We pick a test value in each region. This would be negative 2. I'd pick 0 here. And that's 1.3 repeating, so I'm going to pick 2. We write down our two factors, which is x plus 1 and 3x minus 4. Our outcome that we hope for is less than or equal to 0. So we're going to be circling negatives at the end. So negative 2 plus 1 is a negative. Negative 2 times 3 is negative 6, minus 4 is negative. The two signs in the middle get multiplied together, and that makes an overall positive. 0 plus 1 is positive. 3 times 0 is 0, minus 4 is negative. Positive times negative is negative. 2 plus 1 is positive. That's 6 minus 4, which is also positive. Two positives make a positive when we multiply. Since we were looking for less than or equal to 0, we circled the negative case. So the answer is negative 1 to 4/3 with both of them with a bracket. Okay, let's look at C. The problem with C is that we don't like our x squared to be on that side. So if we subtract it over, we're going to create a little bit of a problem for ourselves. So I subtracted the x squared over. We don't like our leading term to be negative. So let's divide everything on both sides by negative 1. So that makes this x squared minus x minus 12. This flips to greater than or equal to, and that's still 0. You want your polynomial on the left side when you're doing your chart. So that's why I moved everything over there. This factors into x minus 4, x plus 3, greater than or equal to 0. My critical values would then be a positive 4 and a negative 3 if I solve both of those parts. Negative 3 is the smaller one of the two, so it goes first. Because of the equal to bar, these are both closed. So negative infinity to negative 3 with a bracket, negative 3 to 4, both with brackets, bracket 4 to infinity. My test values, I would pick negative 4, 0, and 5. Plug them into x minus 4, x plus 3, and we hope for an outcome of greater than or equal to 0, which means we're looking for positives this time. Negative 4 minus 4 is negative 8. Negative 4 plus 3 is negative 1. Negative times negative is positive. 0 minus 4 is negative. 0 plus 3 is positive. Negative times positive is negative. 5 minus 4 is positive. 5 plus 3 is positive. Positive times positive is positive. We have two regions that are positive, so my answer set is negative infinity to negative 3, bracket, union 4, bracket, to infinity. Okay, let's talk about E. We need to move that 16 over by subtracting. I think I can factor this one, x squared and x squared. And this would have to be a plus 16 and a minus 1 to multiply to negative 16 but add to 15. This guy right here does not factor in the real numbers. So it gives us no critical value, okay? This one does factor, so I'm going to go ahead and factor it. So I would have x plus 1, x minus 1. So I get two critical values from this last part, a negative 1 and a 1. So if a part is non-factorable like this, if it's not specifically quadratic, if it's two perfect squares with a plus, that is not going to give you a critical value because that's an imaginary group of solutions. Critical values are real numbers. So then we put our negative 1 and our 1 at the top. This has no equal to bars, so these are both going to be open. This is negative infinity to negative 1, negative 1 to 1, and 1 to infinity. Test values could be negative 2, 0, and 2. You do need to place all three of your factors, so I'm actually going to write something a little bit smaller so I have room. There we go. So this would be x squared plus 16. Even though it doesn't give us any critical values, we still put it down when we do our factor chart signs. And then this needs to be less than 0 overall. So negative 2 squared is 4, plus 16 would be a positive still. Negative 2 plus 1 is negative. Negative 2 minus 1 is negative. Two negatives multiply to make a positive. 0 would just give me positive, positive, negative. So that's an overall negative since there's just one negative. And 2 would come out as positive, positive, positive for an overall positive. So the less than 0 part happens in the middle from negative 1 to 1. Okay, so that's the polynomial portion. We now have some more examples from the rational inequalities. There was a couple that I skipped at the beginning, and we're going to talk about those. This one specifically because it factors on the bottom, but the top doesn't. So this one does not factor, but this does. This factors into an x squared, or excuse me, x plus 3 and x minus 3. Do not cancel out the x minus 3's. You will lose a critical value. We don't reduce this. We don't want to lose our critical value. Okay, so my critical value on the top, since this has a top and a bottom, is 3. You don't get any critical values from something that doesn't have any real answers. Remember, x squared plus 1 is, again, perfect squares with a plus between them. That means that that's imaginary solutions. The bottom, hang on just one second. The bottom has two critical values, the negative 3 and the positive 3. I wanted to show you this one specifically because we have the same number on top as we do on bottom. It's still going to be a critical value, except we always defer to the open circle when you have it on both top and bottom. So if something shows up on top and bottom, it doesn't matter if there's an equal to here. We always defer to the open circle because you don't want to divide by 0. So this is also going to be open, and since this is a repeat, we don't worry about it being opened or closed. We've deferred to the opening in the bottom. And then remember, this part right here gives us no critical values because of imaginary solutions. Okay, so we just have negative 3 and 3, and they're both open. So this is negative infinity to negative 3, negative 3 to 3, and 3 to infinity. Test values would be negative 4, 0, and 4. Always put all of your factors, so x squared plus 1, x minus 3, x plus 3, x minus 3. Now you could argue that maybe you don't need to write the x minus 3's in your chart since they technically would cancel out. I go ahead and write everything because that's less likely to make me make any kind of sign errors. And we want greater than or equal to 0. So negative 4 squared is 16, plus 1 would be positive. In fact, anytime you have an x squared plus a number, the whole row ends up being positive. It just can't ever be negative. Negative 4 minus 3 is negative. Negative 4 plus 3 is negative. Negative 4 minus 3 is negative. 3 negatives make a negative. 0, you just get the sign, so that would be a negative, a positive, and a negative. So 2 negatives multiplied to a positive. And for the 4, everything will come out positive. So that's going to be a positive overall. Now, this is the scenario I wanted to show you guys that we hadn't seen in class yet. The outcome we want is positive. Notice we have two positives back to back. If there's a closed circle in between them, you just say it's the beginning of this interval all the way to the end of this one. If there's an open circle between them, we have to skip over that value. We have to make sure we keep them separate. So this is negative 3 to 3 unioned with 3 to infinity. What that really says is this is everything from negative 3 up to positive infinity except we skipped positive 3. And that's because of the dividing by it would make it come to a 0. Okay, similar one here. We need to factor that bottom. Some people like to write the x plus 3 squared out. It doesn't really matter, but if you want to do that, you can. This would be x plus 2, x minus 2, less than or equal to 0. So my critical values from the top, x plus 3 is a repeat of itself, but it's on top all, so we don't have to worry about whether or not it's going to be open or closed. It has nothing to do with the bottom. The only time we ignore the top setting is if the same factor is on both top and bottom. So this guy is a negative 3, so is his next one. Now be careful with 2 minus x. If we solve that, that says x is 2. Okay. For the bottom, we get a negative 4, a negative 2, and we also get another 2. So because this 2 showed up on top and bottom, we only use the bottom one for whether or not it's opened or closed. So the top part, the negative 3 is going to be closed because of the equal to bar. Bottoms, remember, are always open because you don't want to divide by 0. So we place these on our number line from least to greatest. Negative 4 is the smallest. That's with an open circle. Negative 3 is the next one, and that's with a closed circle. Then negative 2 with an open circle, and positive 2 with an open circle. So this is the interval negative infinity to negative 4, negative 4 to negative 3 with a bracket on the negative 3, negative 3 to negative 2, negative 2 to 2, and 2 to infinity. Something smaller than negative 4, we can use negative 5. Between negative 4 and negative 3, I'm going to use negative 3.5. Between negative 3 and negative 2, I'm going to use negative 2.5. Between negative 2 and 2, I'm going to use 0, and bigger than 2, I'm going to use 4. Okay, so be careful when you place everything here. I had an x plus 3 squared, which you can write x plus 3 squared if you want, or you can write it twice. On top, I also had a 2 minus x. And then on bottom, I had an x plus 4, an x plus 2, and an x minus 2. Our goal for this one, let me extend all my lines, is that we want it to be less than or equal to 0, so negatives overall at the end. So negative 5 plus 3 is negative, which will also be this answer. 2 minus negative 5 is actually 2 plus 5, so that's positive. Negative 5 plus 4 is negative. Negative 5 plus 2 is negative. Negative 5 minus 2 is negative. 1, 2, 3, 4, 5 negatives makes a negative overall. Negative 3.5 plus 3 is negative 0.5, so that's going to be the same for that one. 2 minus a negative will actually be a positive. Negative 3.5 plus 4 is 0.5, so that's positive. Negative 3.5 plus 2 is negative. Negative 3.5 minus 2 is negative. 4 negatives overall, that makes an overall positive. Negative 2.5 plus 3 is positive, and that will be the same for this one. 2 minus 2.5 is 2 plus that, so that's going to be positive. Negative 2.5 plus 4 is positive. Negative 2.5 plus 2 is negative. Negative 2.5 minus 2 is negative. 2 negatives make an overall positive. 0 would give me positive, positive, negative. Oh, excuse me, no, positive. Yeah, you got to be careful with that guy. You don't always grab the middle sign. That's only if the number is afterwards. When it's 2 minus 0, that's positive. And then positive, positive, negative. 1 negative is an overall negative. 4 plus 3 is positive. 2 minus 4 is negative. 4 plus 4 is positive. 4 plus 2 is positive. 4 minus 2 is positive. 1 negative is an overall negative. So this is what I was talking about. Sometimes you get some weird combinations of signs that are not always alternating. So we have this negative here. We have this negative here because we want less than or equal to 0. And we have a negative here. The problem is anytime you have a closed circle, that is also a solution. So even though there's 2 falses here, we don't want pluses, they surround that. We could still equal 0 at that number. So negative 3 by itself is a solution as well. So let's write out what our answer would look like. So this is negative infinity to negative 4 unioned with the single number negative 3. So we put it in a little set. Unioned with negative 2 to 2, unioned with 2 to infinity. Notice this we keep as separate because the opening between them is open circle. And that would be the answer for that one. So that one's actually really hard, but I wanted you to see something that had some variety. Okay, for D, we're trying to make sure we have everything on one side, and then we have our critical values, remember, of top and bottom. So can we factor anything is usually the first thing if I already know I have my 0. And the bottom is perfect squares with a minus between them, so it's 4 minus x and 4 plus x. So my critical values from the top, when does this equal 0? That would actually be at 0. So we won't be able to use 0 as a test value in version D because it is one of our critical values. And then for the bottom, one of the things that makes this 0 is a positive 4, and this one would be a negative 4. The bottom is always open, and the top is also open here because we don't have an equal to. So we're going to place everything down on our number line. Negative 4, 0, and 4. Everything's an open circle. So this is negative infinity to negative 4. Negative 4 to 0. 0 to 4. And 4 to infinity. So I can use negative 5, negative 1, 1, and 5 as my test values. So I have a 2x on top, a 4 minus x, and a 4 plus x. And I hope for an overall negative sign at the end since I want less than 0. 2 times negative 5 is negative 10. 4 minus negative 5 would be 4 plus 5, so that's positive. 4 minus 5 here would be negative, so 2 negatives make a positive. 2 times negative 1 is negative. 4 minus negative 1 would be positive. 4 minus 1 would be positive as well. So 1 negative makes a negative. 2 times 1 is positive. 4 minus 1 is positive. 4 plus 1 is positive. So that makes an overall positive. 2 times 5 is positive. 4 minus 5 is negative. 4 plus 5 is positive. 1 negative makes an overall negative. So we don't have to worry about any floating points or single points because there's no closed circles in this problem. So this is -4 to 0 and 4 to infinity. All right, so let's move on. Okay, I believe we just had f and g left. So for f, we need to get 0 on one side first. So we'll subtract over that fraction that's on the other side. We want to get a common denominator, so we're going to multiply the first fraction by an x minus 5 and the second fraction by a 2x plus 3. That means our denominator will now be a 2x plus 3 and an x minus 5. Work out the top. That becomes 2x minus 10. Hang on just a second. There we go. 2x minus 10. And then this would be negative 4x and negative 6. Don't forget your sign. All over the 2x plus 3 and the x minus 5 less than or equal to 0. That gives me negative 2x minus 16 over 2x plus 3 and x minus 5. Don't pull out that negative 2. It's just going to cause you to mess up your signs. On top, I would just leave it as it is. So my critical value for the top, I set that equal to 0 to solve it. That would be add 16 and divide by negative 2, so it's negative 8. For the bottom, this would be a positive 5 and a negative 3/2 if we solve both of those. The top obeys the symbol, so it's going to be closed because there's an equal to bar. Bottoms are always open. So then when we draw our number line, the smallest of the numbers is negative 8, then negative 3/2, and then 5. I don't have a lot of room to write the intervals, so I'm just going to do the closed or open circles. So this is closed, open, and open. This would have a test value of negative 9. I could use negative 3 here. I can use 0 in this group, and I can use 6 here. We plug that into negative 2x minus 16, 2x plus 3, and x minus 5, and we're hoping for less than or equal to 0, so negative symbols overall. Negative 9 times negative 2 is positive 18, minus 16 would be positive 2. Negative 9 times 2 is negative 18, plus 3 is a negative answer. Negative 9 minus 5 is negative. Two negatives make an overall positive. Negative 3 times negative 2 is 6. 6 minus 16 is negative. Negative 3 times 2 is negative 6, plus 3 is negative. Negative 3 minus 5 is negative. Three negatives multiply to make a negative. 0 is going to be negative, positive, negative. Two negatives will then make a positive. And 6 will be negative, positive, positive for an overall negative. So my two groups, since I want less than or equal to 0, are the negatives, and that is negative 8 to negative 3/2. That's that group right here, unioned with 5 to infinity. Okay, and then the last one, we need to move this 1 over x minus 3 over. Get a common denominator, so 3 times x minus 3 minus 1 times 5x plus 1, all over the common denominator of both denominators. Work out the top. That's going to be 3x. Oop, almost out of battery. Hang on just a second. That's going to be 3x minus 9 minus 5x minus 1. That's negative 2x minus 10 over 5x plus 1, x minus 3. If I solve the top, I get negative 5. If I solve the bottoms, I get 3 and negative 1/5. The top is closed because of the equal to bar. The bottoms are always open. So I'm just going to do this one real quick before I run out of battery. So this is negative 5, negative 1/5, and 3. So this is closed, open.